Hi, my name is Shadi Atia, professor at Liège University in Belgium, and today I'm going to talk about the protocols and equipment for your experimental research. Today's presentation is part of a playlist on experimental research, and it's a follow-up of 3 previous presentations. I strongly advise you to watch the previous presentations. Well, experiments are at the core of laboratory research, and therefore the audience of this presentation is mainly postgraduates and scientists who are conducting or seek conducting research in the field of social sciences, life sciences, medical sciences, and or natural sciences. And for sure it is also dedicated to mentors and supervisors. But let me place first the presentation. It is placed in the context of experimental research. And when we talk about the different methods of research, we have the quantitative research, including modeling, observational, and experimental research. And we have the qualitative research that can be sometimes mixed, and some people follow a mixed research approach. But in this presentation, we are here talking about experimental research that is considered as manipulative, and it is the study design that alters variables or one variable for comparison against control conditions or baseline against the observational approach. Now, the objective of today's presentation is to enhance your capacity to conceptualize, design, and conduct your experimental research, and to prepare your equipment, get familiar more with your protocols that you will use so that you can be ready to perform your experiments. The content of today's presentation is a general introduction about protocols and equipment, experimental protocols, the history of experimental protocols, preparation of your equipment, how to inventorize your equipment and calibrate them, and finally some takeaway messages. Let's start with the introduction. So what is experimental research? The main purpose of experimental research is to contribute to knowledge by establishing relationship between variables, and an experiment is a study of a cause-effect, and it differs from non-experimental method in that it involves the deliberate manipulation of the variable or more while trying to keep all other variables constant. And in this sense, experimental research is based on experimental protocols that are key when planning and performing experimental research, especially in relation to the reporting of materials and methods. By providing guidance for the key content to be reported, we aim to make it easier for authors to report experimental protocols with necessary and sufficient information that allow others to reproduce an experiment. Because the standardization is very high in experimental research that you must allow for replication and repetition. And therefore, when you follow a standardized protocol, it will help you and others to repeat the same experiment. Also, it helps to promote consistency across laboratories by delivering an adaptable set of data elements. It's unimaginable that a certain test that is standardized universally can be conducted differently or through different protocols in different countries. Actually, it is not logic. To have a certain test and to have the reliability in the test, it must be standardized, and protocols can help with that. So it also helps to make it easier for reviewers and editors to measure the quality of the submitted manuscripts if you are seeking at the end publication against an established criteria. So therefore, the experiment protocols are very important, and they can allow you to bring more transparency, more consistency, accuracy, and reliability in your results. Here is an example of an experiment. We have a subject, a human being, who have to fast overnight. Then we have a standard breakfast for 10 minutes. And then we will conduct experiment 1, experiment 2, and then we have anticipated symptom rating after, and we can do that through testing and through questionnaires. And as you can see here, we have in the protocol more definition of what is the type of food that will be located in the first block of experiment 1. The second block, here we have vegetables, we have here pancakes, and then we have another experiment number 2 that is part of the protocol that is talking about free exploration of eye tracking with a visual tracking for strawberries or vegetables and compared to fudge and chocolate. So here I am describing visually my protocol so that it can be repeated and that others can understand what was done exactly. Now, what else about experimental research, and what else about this lecture? It's not only about protocols, it's also about equipment. So the 2 things you need to be very aware about to be ready for conducting an experiment: the protocols and the equipment. Many specialized tools and items of equipment are required to carry out modern laboratory processes and operations. So the space required for effective equipment cleaning, decontamination, and maintenance must also be considered. And if you want to know more about the spatial design of a lab and the lab setting, you can follow the previous video. The manufacturer instructions for positioning of each piece of equipment must always be followed before incorporating into the laboratory design so that it can be operated safely. Instrument calibration and maintenance is vital, so keeping track of all processes connected with instrument calibration and maintenance is quite a challenge. And get a solid comprehensive equipment list for your lab so that you can trace it. And as the lab planner or scientist, in this case, in many cases, the lab planner or the lab manager are scientists, scrutinize the equipment list you receive from your client carefully. So this is an example for a very busy lab when you can see different people operating and running different experiments with storage and so on. So this is the environment where we talk about the importance about protocols and the importance about equipment and their maintenance and the associated training or skills that you need to run these equipment. So let's go more into detail in experimental protocols. Well, what does it entail to have an experimental protocol? Well, an experimental protocol entails having specific objective, background and rationale, concise statement of design, selection and enrollment of the subject, how is this done, what will be the interventions, what are the methods or the procedures of data collection, processing and quality assurance, and what are the participants' rights and confidentiality, informed consent, all ethical concerns that are considered. Here we are having an example of a human-based testing or experiment. So the same can apply for any different type of subjects. Also, what are the intervention of the experiments? I need to talk about the products, the dose, the quality, the training, the administration, and the reproducibility of the interventions. These are all part of my description of the intervention that will take place, and it must be part of my protocol. Also, I have in the protocol definition define what will be the intervention that will take place. So now the number of intervention, the length, the range, the interval, the frequency, amount of practice that is needed for the subject or for the manager of the experiment, the different combinations that will take place. All these parts are very important. This is if we are talking about human beings, for example. Here is a hip accutation, here is an ankle accutation, how I'm going to run that, how many times, how I'm going to brief the subject, and so on. It can be also applied, for example, in the case of material sciences. Here we are talking about sand, silt, and clay samples. So I can say what are the measures, and what are the parameters that will be measured or investigated. What is the sample size? What are the measurement unit? How frequent I will repeat the test? What are the temperature? Don't forget, in chemical or in material science, the temperature is so important, for example. All these are important to include. And simply, we also talk about the types of measurement will take place when we are talking about the protocol. So the protocol covers all these aspects. So how variable are the measurements? How accurate are the measurements? Am I going to do a pilot measurement or not? Can other measures the same parameter, and will anyone come up with the same result? This is a validity and a very important question to make sure that I standardize of the way of measurement so that it's not subjective to myself or not subjective to my own research or lab conditions. I must make sure always that the measurement can be repeated by others. Also, I have to check the measurement sensitivity and the uncertainty, and I have to calculate always the confidence interval. All these are part of my protocol that I have to develop, and I have a protocol for my experiment. It has to be a separate document that I can already add if it's needed to be read or accessed. Now, one of the best practices also if I'm preparing a protocol is that I can publish my protocol before even running the experiment. And in this sense, we call it pre-registering the research project or pre-registering your research protocol. And here you are laying out the hypothesis, the method, the analysis, the plans, the intervention that we talked about in writing before you collect the data. And this brings more credibility, shows your commitment to the specific research approach, and makes sure, assures that you are not going to manipulate the results. Another important aspect while we are talking about protocols, I need to study the history of the protocols that are developed in my field. So this is very important, and many researchers neglect this aspect and they think directly jumping into running their experiment. No, it's very important to take time that while you are conducting a literature review is to review the existing protocols. So you must look at the history of similar protocols. So before running an experiment, it's important to gather information about the history of similar measurement. Have similar measurement been performed before or not? You ask yourself this question. You ask also what for were these measurements done? What was the setting for these measurements? And you have to conduct a literature review related to the research topic. So in this sense, you have a better knowledge on the research topic, you get a better understanding of the research question and hypothesis, and also the literature review will help you to provide insights on the past experiment performed in the field. Without this step, your work will not be complete and it's considered as non-professional. So it's very important to take into account, learn and study about the protocols that you will use, and also investigate the history of the protocols related to your treatment that you want to conduct. Don't hesitate, you check ISO standards in your field depending. For example, ISO standards, they can ensure safety. You can look for existing standards. Why ISO standards are important in experimental research? Because they help you with standardization with the measurement protocol. Many protocols are based on standards. They help the definition of the experimental setting. They are applicable at an international level so that you make sure that the same way of measuring is already universally applied, ensures that the results are the same with a known margin of error, the confidence interval for sure, even if performed by different people. And this helps you to conduct your protocol or develop your protocol in a very smooth and simple way. So choosing the right ISO standard can be crucial depending on the type of your experiment. And if you don't find an ISO standard or a local national standard, a European or American or whatever, national or regional, just check protocols. There's very common protocols depending on your field. And unfortunately, not many fields are used to use protocols, but it's more used in the medical world. And it is common best practice. Now, I'm done with the protocols. I learned about the existing protocols. I have my own protocols and I have everything defined regarding the treatment that I will conduct, the way of my test, the conditions. Now we need to talk about the second part of presentation, equipment. I need to prepare my equipment. Now, when I talk about equipment, I have to ask myself what kind of equipment I'm going to use. What is the history of measurement techniques in this domain? And what kind of equipment were used to measure this variable? Also, I have to look at the creation of the equipment. Am I going to create my own equipment, or I'm going to buy it, or I'm going to lease it? It depends. So it's very important. Here is an example for a scanning probe microscopy that you have to learn a lot about this technique. You have to know how you can conduct the microscopy and how you can do the experimentation. So it's a very sharp tip that can physically scan the surface of a sample to obtain information at the atomic level. So such devices, if you want to use such a devices, you need to know that, first of all, how you can use it, do you have access, and so on. Are you trained enough to be able to use it? What will be the protocol that you will use? What will be the alternative if this device is not accessible? What will be the plan B? So these are all considerations to look at. And as part of your preparation to your measurement equipment and your tool, that you invest in training. Unfortunately, many researchers, they go into the lab without training, and that's not the best practice. Try as much as possible, at least if you know which lab you are going to visit, to make sure what kind of equipment do they have, and are you familiar with those equipment or not. And when you arrive, you can ask for special training to make sure that you are performing and you are able to conduct your experiment. For example, the Fourier transform infrared spectroscopy, it's a very difficult device to use. Not everybody has an idea how to run the samples and how to make sure that the measurements are done correctly. So it's very important, and how to read the reports and how to validate it, how to make sure that also that this device is giving right results. So it requires experience and requires investment. So it's very important to invest in your preparation and your training. So measurement equipment are very important, and there is a lot of measurement tools and data collection equipment depending on the field of experimental research that you are placed at. And the choice of the measurement tool depends on the type and the field of the study and the variables that you are investigating, and the accuracy or the level of accuracy you need to conduct your experiment. Those are very important aspects related to your equipment. Another important issue is the sample registration. Now, if you are using samples, you need to have registration and providing annotations that ensure your samples, dispatches, and systematically are verified during the results processing. And you must avoid the common mistake associated with transcriptions that are particularly when verifying the large data set. Consider electronically systematic inputs with centralized storage destination. So try to avoid these kind of manual inventories for specimens. You can do it in your lab notebook, but you must have in parallel a digital system. So this is very important. Now this will take me to the fifth element before terminating the presentation, the inventory management and your equipment calibration. This is very important. When we talk about calibration, it's one of the key issues related to experimental research and to the use of equipment. So calibration is the assessment of the error of measurement device by comparing a measured value with a reference standard of the value. For example, if we have a thermometer and we want to measure the temperature with a thermometer in a boiling water, I need to compare the result with a known value of the water temperature at the boiling point, and then I can deduce the thermometer's range of error. And normally we do calibration every 6 months or every year, depending on the equipment and the device. And it is very important because it will allow you to find out any error when you are conducting your test. So therefore we always put a range of error related to the equipment, and it allows us to verify the accuracy of the device. So calibration is so important in this regard, and measurement tools comes with an uncertainty that needs to be taken into account when we conduct the experiment. The principle of calibration is to compare of a measured value and a reference value. So this is the basic, and for some tools the difference has to be calculated, taking into account the uncertainty of the global results. So we can integrate the range of error of my equipment in the confidence interval overall value, or I can have it separately, and for other tools the device is able to take the difference into account if it's correctly set up. So some devices will allow you to have a kind of correction setup. You can on-spot calibrate, and then you have a very high accuracy depending on the level of investigation. So for a spectrophotometer, for example, you can measure the wavelengths of a reference solution, then you adjust the displayed value so that it is corresponding to the reference standard value of the reference solution, and then you can start your real measurement for your real sample that has an intervention. So these are all important aspects. Also, you need to have an inventory, and you need to have a management policy for your samples. So laboratory inventory management is crucial in experimental research. It can be complicated and troublesome. Inventory management takes up a lot of time and requires concentration. So you must invest in a laboratory information management system. No way you can get out if you have a big testing batches of testing and you have a lot of experiments. You must have information management software that can measure, record, and control inventories as well as manage the laboratory equipment. This will be a win-win, so that when on site you can manage the sample and you can manage also the equipment and you can trace them. You have the dates of the purchase date, the calibration date, and so on. So this is very important, and I recommend you to sign a general contract for continuous calibration. For example, in my lab, I have all my calibration every year in June, for example. So I send all my equipment for calibration and then I get them back. Also, something important not to forget before we finish today's presentation: insurance. Every equipment requires an insurance policy to protect the user and the equipment owner of the event of an accident or a human error, and start with a risk assessment depending on the situation, and based on that you can have a third party damage or injury inquiry. And then you can have a damage. Also, don't forget about the damage to the environment or to the neighborhood caused by uncontrolled discharge of hazardous and toxic vapors and chemicals, for example. And seriously, if you are looking for peace of mind, I strongly recommend you to have a small amount of a premium invested against any risk related to your equipment and your lab damage or errors, so that you are not stressed home that any accident can happen, especially when you are not having a full access or control on your lab. So these are some best practices. Well, this is the end of today's presentation. We talked mainly about the experimental research protocols and the experimental research equipment. And in these coming slides, I will wrap up by giving you some takeaway messages. Define your workflow when you are conducting your experiments, and you can get visual drawing for your whole process. Why don't you do a process map for the whole experimental process so that you can have a look what will happen and share it with others. This can be already a very helpful visual guide. Sample registration and analysis is crucial, so registration and providing annotations ensures your sample dispatches and systematically verified the testing results. Invest in a laboratory information management software that can measure, record and control inventories as well as manage laboratory equipment, especially if you have equipment that needs to leave the lab, if you are borrowing it, and when it goes to calibration and so on. So I strongly advise you to have a digital or a software that helps you to manage your lab inventory and for sure the sampling that you are using. Also learn about the history of your measurement equipment. It will be too naive that you are placed in a specific domain or a specific field of specialization and you don't know what are the most famous equipment that are used in this field, and you don't know how they evolved, you don't know what are the top-notch equipment today in your field of investigation. Even if you have no access, just Google, fetch, check any online training or whatever kind of training material that you can access so that you know about the equipment. It's a shame to start your PhD or your postdoc studies or any postgraduate studies in research and you still don't know enough about your equipment. If you have time, invest in it, and if you cannot have it beforehand starting, first thing you talk with your supervisors, you tell them I need to have training to learn about this equipment. So think beforehand and always invest in this aspect so you can know how to use the equipment. Very important, calibrate your equipment, part of the equation. No calibration. If you don't communicate the calibration information when you are working, most of the time the paper can be rejected or required for modification, so it's very important. Learn about the history of your protocols, learn about the most common protocols, how they evolved and what we are doing today and what we are not doing today and why, because maybe you will be helping in introducing a new updated protocol or refining a protocol, and this can be also a good contribution. So write the protocol. Anyone should be able to replicate your study, and therefore the protocol should be very well written. They might need your manual or procedure too, if people ask you to share it. If it's not something confidential, you can disclose it, do it. Pre-register your research or your project protocol for review and transparency, and create a single document for the study procedure. This is my final advice for today's presentation. I hope the presentation is useful. Well, this presentation was part of a playlist on experimental research. I hope you can like this presentation, so please like and subscribe because this will allow me to continue. And in the same time, I invite you to watch the previous and the following videos because this follow-up will give you a good idea about how to conduct experimental research and how to be prepared. Well, today's presentation was about protocols and equipment. I wish you the best of luck. I hope you will be mastering your experiment, you will be confident in the lab, and I hope you can do a very good research and very good outcome. Thank you very much.